Okay. Are we online now? Hello? I see a video and I hear sound, which is great. Okay, then let me also enable the chat once more. So chat should also be okay. YouTube Live Control Panel. What is that? Just close it. Let's have it like this. Okay, I think we are good to go with day number 2 of our platformer game. We don't want to update that one here. And that one we renamed to platformer. Good, so what we want to do today is too much. So that's for sure, because I'm a little bit tired today. So this is definitely too much for just one evening. What we will do is actually we will spawn the collision objects for the tiled map. That should be okay. We also want to spawn a player, maybe not perfect, but that's totally okay. And this integrate box 2D for player character and keyboard input listener, that will be for day 2.2. So there we definitely want to split it up. With we, I mean myself, because it's too much. So we will move that here. But I also thought of actually doing the profiling stuff. That one we will do today. And it's actually the first thing that we are going to do today, because we want to check if what we did so far until now is properly working. So in theory, we should only have one draw call, because we just have one texture, the big texture atlas and the map behind it. And even if we draw those layers one by one in a loop, we should still not flush multiple times and have multiple. Maybe draw calls, we might have multiple ones. I'm not sure what was the difference there, but it should be just one flush to the sprite patch. And that should be it. So we will start with that. Also looking forward to, if you don't follow that, but I follow the IntelliJ blog from time to time. And there is a new version coming up, the 24.1 version, which has some very, very nice feature that I'm looking forward to. First of all, it promises that with this indexing that is always happening with IntelliJ, that you can already start working during the index phase, so that you can work a little bit faster. I hope that helps at work, because their indexing takes 1 or 2 minutes, which is quite annoying. And also what I saw, it has some, I think, AI, local AI stuff, which helps with auto-completion of a single line. So it thinks what I want to do and just, fulfills everything so that I can complete a line. And hello, Christoph. I will just call you Christoph from now on. So, first thing we want to do is the profiler. I'm not sure if I ever showed that in a tutorial. I maybe did it, but not 100% sure. What we do here, or what I normally do, is that I just create a new system for that, which is the easiest thing to do. And normally I combine the profiling stuff and also some other debugging things. But this time I want to split it up a little bit. That might make it easier in the future, that you can enable or disable certain debugging functionality on demand and you don't get everything at once. So for that, we will make, let's call it GL profiler system. That system is, let me zoom in. Maybe I forgot that last time, I'm not sure. And this system is again, an interval system. I think it doesn't need to be anything else. Each frame, that's for sure that we want that we need that. And other than that, I think it just needs an instance of the profiler, which I think is called GL profiler. But I might need to look that up. So it needs the graphics context, which would be GDX graphics. And I think that should be it. And one thing that we have, so in the constructor there, we could actually do that in here. So there we just apply it and we call the enable functionality, which means that this profiler is enabled. And I think a profiler does not need to be disposed. No, you can disable it and enable it on demand. And that's it. And what is important, that every tick the profiler gets reset. And then what it does, it will see, is there maybe some documentation what it does? So create a new instance of GL profiler to monitor graphics instances, GL calls. So it somehow is monitoring what we are doing with the OpenGL graphics context in the background, and we can profile what it is doing. And that is what we want to do today. Should be a simple thing as a starter. Hello, Neftatni. So what we want to do here is just that we want to log something. I forgot what is the best practice for the logging stuff with LibGDX, but I think it should be something like, most likely just a companion object where we add the profile system and then we should get the correct log information. And of course, we need to control that, and that would be just some debug information, of course. And here we want to print out now some information. And the first thing that we want to get is from the profiler, we want to get the draw calls. What's the difference between calls and draw calls? Let's check. Returns the total OpenGL calls made since the last reset. I think there we don't care because that most likely ends up at the hundreds of calls that we could maybe do. What is draw calls? The total amount of draw calls made since the last reset. Maybe that's the one that we want to have. But there should also be one texture bindings. That is a good one. So that should be just one in our case. So I would... shader switches, we don't have that yet. So I would debug for now the texture bindings. Let's make it bindings. And I'm just thinking, I think in the log, it's not really that useful. Maybe we want to have that in the application window. That makes it easier. I think that's app. And then is it title or something? Or how is that called? I forgot how, or is it in the graphics context? Set title, yeah, I think that's the one that we want. And is there also actually a get title? We don't really need that, but just curious. No, there isn't. So we don't need that. We will just add whatever we wanted to do in here. We moved it up here. So we have the bindings, and then we also have the draw calls. And we will check in a moment if that is the information that we actually want to log. And the logger we can actually skip. We don't need that anymore. That's it. So let's go to, I think we called it game screen. And there at the end of a frame, we will add this GL profiler system for now. Later on, we will enhance that a little bit, that it's not added all the time. It's only added at some point. But for now, that should be good. And my expectation is that the draw call should be maybe 1 and the texture bindings for sure should only be 1. That would be my expectation at least. So we have a texture binding of 1 and 1 draw call. Okay, so that is what I expected, because we just have one texture atlas. That's which contains all the graphics that we are seeing here. So that's the single texture that needs to be bound. That makes sense. And draw call, since everything can be batched together, since it's just one texture in the background and we don't do anything fancy with shaders and stuff like that, one draw call also makes sense. What I am now interested, that's just the final thing. What is then actually the last information that this profiler can give us? I made some mistake. There was one more, which was called, I think, just calls. And what is that? Number of calls. That could be maybe 22. Because we have 22 tiles. 1, 2, 3, 4. Okay, let me count that in tiled. That might make sense that it's really just the amount of single textures, or in our case, a texture region that gets rendered. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 40. Why is it 22? We don't see the entire map. Yeah, we don't see the entire map. So it's 4 by 3, 4, 5, 6, 7, 8, 9. But even that would be 9 times 4. That's already 36. I don't know why it's 22. Why is it 22? Does anyone know? Does it change? It was 24 at some point. When we resize for whatever reason, then it's 24. But why is it 22? I don't understand that. I really don't understand that. Whatever. I think this information is not, at least for me, it's not the important one. I mean, okay, if you have here maybe tens or thousands of calls, that's maybe not that good. I don't know. The important piece of information that I want to have is the amount of texture bindings and the draw calls, because especially the bindings, you want to keep that at a minimum, because that's an rather expensive operation in the background when OpenGL needs to bind a texture. So we don't want to have a lot of these calls. Good. So the first part, that was a small one. That was an easy one. Done. Did I use? I did use this 100% marker. So let's do that as well. Now the more interesting one for today would be the spawn, the collision objects for the tiled map. And there, what we want to do is we go to our tile set, which has quite an irritating name, but no one sees that name. So who cares? We will just roll with that name. And we want to use now the Kachel Kollisions Editor, so the collision editor. So when we have it here, we can, I think there was a button to, let me make that a little bit bigger. Wasn't there a button to zoom in? Maybe not, then I zoom in manually. And one cool thing is that you can just press one of these two. So detect the edges or whatever that's called in English, and then it automatically fills in a shape, normally a rectangle shape, for all the visible pixels of that tile. So in our case, that's not 100% accurate, because I would say the black border in here, that should not be a collision. So there the character for sure can go inside. Can you somehow make it more like magnetic shifting, that it goes pixel by pixel? That's somehow possible. It should be, but I'm not 100% sure where it is. Let me check. No, that's not what we want. Maybe I'm hallucinating it that was available, but I thought that there was some magnetic feature that it goes really pixel by pixel. Whatever. So we just do it like this. So here we have, does it really? That's annoying. Why? I'm 100% sure there was an option like that. Okay, so we just remove the black stuff. Not even sure, maybe the character can even go a little bit down below. So maybe something like that. So that would be the collision area of our characters when they go there. And at the bottom, actually, we don't really care because most likely, can he hit his head when he goes there? Yeah, maybe. So let's be a little bit more accurate. So let's say that's the bottom bounding area. And that's it for that specific tile. Let's keep calls count in title to see when and how it will change. Okay, so let's bring it back. We can do that. But would be interesting. So for me, I personally don't understand why it was 22 or 24. I don't get that. Because there are not 22 unique tiles. And also for sure there are more tiles drawn than 22. So why is it 22? That's interesting. Good, so we have that one. Then the next one is this one. There also, I think we went below here a little bit like that. Then up we go like here. And the last piece would be this one. There we also go down a little bit to the right and a little bit to the top. Okay, what I want to see is the collision information. Is that now shown on the map itself? Ah, yes, it's shown here. So if we do everything correctly, we should get, it's you can maybe hardly see it, but we should get this collision information in the game. What I already see a little bit problematic, which I need to fix, is that we have here not the exact same height. So there's a little bit of a gap that could be a problem later on when we move around, that we maybe are stuck at those little gaps here a little bit, but we can fix that later on. And I need to Google that. So I'm pretty sure that I can jump in or move it pixel by pixel. I'm just not sure how that worked. Was it with right click? Nah, I don't remember it, but somehow it's possible. And then I can accurately move around here and set the collision box correctly. Good, but that is everything that we need to know. And one functionality that we now need to add is that when we load our game, our map, sorry, so we have somewhere the logic from last time where exactly here. So here we just currently manually fire the map change event to this test map. And there the render system is currently reacting that it is rendering the correct stuff. And now we would need some separate logic somewhere, which is then creating all these collision box 2D objects for us. They don't need to be entities, I would say, but it does make it easier if they are entities. Let me think. Yeah, I think it makes it easier if everything is the same. So if a box 2D body is always connected to an entity, I think that should make it easier in the future. So we will go with that approach. I'm currently now thinking, do we want that to be part of a system? Because what would the system do? This is more like a one-time thing that we are just creating the collision object. So it does not necessarily need to be part of a system, but let me quickly think about that. Hello, ChatSec. Yeah, it was not the first library that I used, LibGDX. I started with, I think it was called DarkGDX, and also some, was it called SFML or something like that with C++ back then. Then some 3D stuff with Irrlicht and Ogre 3D, I think it was called. And then when I started with Java development at university and looked for a game library there or a framework, then I found LibGDX, and since then I like it a lot. I mean, it's of course low level. It's not like those fancy editors in, I don't know, Unreal, Unity or Godot or something, but it has the benefits that you can do whatever you want and structure your game. And especially you can adapt the code to your own workflow, the way you want to work, and you don't have to be, or you're not forced into a specific workflow of these real game engines out there. To be fair, you are of course a lot slower with LibGDX, but I just like it for hobby projects. I have no intention to make a AAA title and earn some money with a game. So for me, that is the best option and makes the most fun for me. So I'm still not 100% sure. What would I need in that system? I would just spawn entities, and does the system need to do every frame? Maybe in the future, because let me give you a little bit of an idea what I'm currently thinking of. So currently we have a very tiny map. It's, I don't know, what is it? 10 by 10 or something. So a really, really small map. So even if we would have here now the player entity, then maybe also some enemies there, I don't know, other stuff. We don't have a lot of active entities in our game. There would be for every collision that we have here. So in total, there would be 10 entities for the collision. We would have the player, enemies, or maybe 20 objects. So that's not the big problem to handle that every frame. But imagine in the future, we might have a bigger map, and maybe at the end, somewhere here, we would spawn already enemies and things like that. And they actually don't need to be processed, in my opinion, every frame, because what is the benefit if an enemy would move here around or does whatever we tell him to do? It shouldn't do that. So it should be somehow inactive and not processed every frame to save some resources. And the idea that I want to try in this game is that I set like a flag on an entity if it's currently active or not. And certain systems which are processing some update logic like AI update logic and things like that, they will only iterate over entities which are currently active, so which have this active flag. And that's so to detect if an enemy should be active or not, that could actually be part of that system that we would need now to spawn the object. So for now, let's just roll with a system and call that for now spawn system. Yeah, let's call it spawn system because that's actually what it is doing for now. So it's again an interval system. And for now, we can disable it because it doesn't need to do anything. That comes maybe later on. So even the onTick method is not really necessary. That's also one thing in the tutorial series on YouTube. If I remember correctly with Mystic Woods, I put everything in a system and also entity spawning and things like that. They were always processed in a specific system and not immediately. And that can cause problems from time to time or make it a little bit tricky if things are introduced in a delayed way. So maybe if I create here an entity and just later on, for example, set its image or sprite texture or whatever, but in some other system before that, I would already try to access the sprite or the texture or whatever, then I get a null pointer exception or whatever. That's just a problem that could be if you don't do everything necessary immediately. So at the moment, at least, I prefer if there is a possibility to do things immediately, that we do that immediately. So meaning that in our case, in the game screen, when this map change event gets fired, then already directly, when I handle that event, I already directly create all the entities, and also the entities itself, they are already created completely. So there is nothing missing, nothing needs to be initialized later on. everything will be available from the start. So at least that would be the goal or the idea. So for that, we need a game event listener here and override the onEvent method. And the only event that we are currently interested in is the map change event. And there, that will be most likely a bigger logic. So there we will spawn the entity. So let's call it like that. And we pass the event.tiled map. So that is everything that we need for to spawn our different entities. So we create another function here where we pass the tiled map. And now we need to parse this map somehow. So there, of course, from the top of my head, I don't know where the collision information is stored. There's also, we can enhance that later on, because there are also different shapes that we need to support. So currently we are just using a rectangle, but there's also the possibility that you use a circle or a polygon, which has an arbitrary shape. All of that should, of course, work, but we can enhance that later on. So let's add that here on the day 2.2, where we will finalize all of that. So support different tiled shapes for spawning entities so that we don't forget about that. Good. The map. From the map, for sure, we need the tile set. How is it called? Yes, the tile sets. There could be multiple ones in the map. And what else do we need? So let me write down what we need here. So we need the tile sets to get the collision information. That's why we need the tile sets. But we also need to iterate over all cells of the map and spawn a collision entity for now. That's a very simple approach. Again, can be optimized in the future. But for now, we just roll with a simple approach. And that should be it. So every cell, I think this is how the data model in the background is. You have a cell. A cell is connected to a tile, and the tile has the tile set information to which it is connected. So in tiled again, coming back to the map, we placed here a specific tile from our tile set. So we picked that one. That one has an index in the background, which links to that tile here in the tile set. And that little tile in the tile set here has the collision information. So that's how it is. So it's, I think, a little bit simpler. We just go over all the cells of our map. So for every layer that is available, let's iterate over let's make it like this. So for every layer, and every layer has a cell or something. Wasn't there a function get cell? Something like that. We need to make a breakpoint because I don't know from the top of my head where everything is stored. So let's do it like this. What we need to do is we need to add the spawn system that it gets processed. So we put it in there and let's make a breakpoint. Hello, Mickey. Thank you for giving out the free education in world full of greed. No problem. I'm happy if I can help some people. And I always enjoy reading the comments and reading about some ideas of motivated people, which is quite cool for me to see that at least for some people out there, my videos are useful and they learn something from it, which is cool stuff. So we have layers, then we have a tiled map tile layer, and that one has cells. Okay, we need to filter then, I would say. So we need here filter is instance, we only want the tiled map tile layer. So those are the ones where tiles are placed. And there for each layer, we want to do something. So that one hopefully has a get cell information. Okay, so there we can get that. So we need here also the width and height of that layer, or is it from the map actually? Yeah, it should be from the map. So a map should have a width. What does that return? 10. Yes, that is what we need. So that's the map width. And we also need the map height. That one should return 10. So we had a 10 by 10 map. And then we just have also a double loop, which means here we would have something for x in 0 until map width, and for y from 0 until map height. We get all the cells, and if a cell is not null, then we want to process it. So we would have here a lot of nesting, which we improve later on. So for now, we go with that. So for x in 0 until map width, that's too much. So it's until, yeah, that's the correct one. We do something, and for y in 0 until map height. And then we can get the cell from that specific layer here. And that cell hopefully has then a tile information. Perfect. And the tile has objects. I think the objects are the ones that we need. Let me quickly check. Do we have here an example? So here you also see a little bit how I debug stuff and how I find out certain things. What do I need? So that's the first layer. Let me quickly check in which layer do we have the collision stuff. Is it the ground layer? Yes, it's the ground layer. So actually, I thought that we are in the first layer. Yes, we have here 10 cells. Why is it only 10 cells? So that is not correct. The ground layer has way more cells. The ground layer has 40 cells. So we are looking for a layer which has hopefully 40 cells. Here's the name. Name object. No, only this one has a name. That's also weird. This one has a name as well. Decoration. No. Ground. So that we are in here, but why? There is a tiled map tile layer cell which contains of 4 cells. What the fuck? What is that? What is that information? I don't get it. How is it stored like that? I remember there is then the difference between the static tile, which we currently have, and I think there is also is it called animated tile, something like that? Animated tile map tile. Yeah, that is the one with the animation that I mentioned last time. Anyway, I think that should be correct. We make a breakpoint here when we find a tile which has some objects. Let's see. Have you considered of releasing your own full game? I actually did that. Not sure if you can still download them, but on the Google Play Store, there are 2 games. One of them, there were 3 games once, but one of them got deleted. I can tell you which one soon. So one game was called Mystic Garden. Not sure if you can find it like that. Also not sure if you can still download it, because I got some emails that I need to upgrade to whatever Android SDK version to have all the security patches and stuff like that. And I never did that. Yeah, this one here, you see it, Mystic Garden. What is amazing, it has a 5-star rating, and I never rate myself, so it's completely random strangers out there which give it a 5-star rating. And to be honest, it's not 5 stars. It's a garbage game. But it was the first ever game that I released, and was fully proud of that because I learned how to upload something to Play Store, what I need to do, how to build the Android version correctly, and all of that, which was quite some challenge for me at the beginning, the first time I did it. But in the end, it worked out. And it seems like over 100 downloads, which I'm also surprised. And the other one would be Dark Matter. That's this one. Exactly. That also has over 100 downloads. I'm really surprised. I guess these numbers are fake. I cannot imagine that so many people downloaded that stuff. And I actually did a tutorial about Dark Matter in Kotlin. That was one of the games that we have developed. There was one additional one which was called Tetrolix. I think I called it like that. Not sure if we can see that. No. So that one got deleted because it was very similar to Tetris, and they don't like that if you put a Tetris clone on Play Store. Now, with a little bit of silence, I will scroll through this list now. So do you understand why I was not allowed to upload a Tetris clone? Yeah, me neither. But actually, I didn't at least not get charged or whatever. I just got an email from, I think it was a lawyer, that I need to put that down. I told him I made the graphics myself. I stole nothing. Everything was written by myself. But he said that's not the matter. The problem is that it's too similar to Tetris itself. And that's why it's, I don't know, the copyright stuff and someone's own, he owns that idea or whatever. So I'm not allowed to upload it. Do you have any experience with Kotlin Android app development? Actually, no. There I have no idea at all. I know a few concepts because I randomly watch some videos from time to time, but I never did some real app development on Android. So they are really no experience. Okay, so here let's make a breakpoint when if cell objects, how was it called? Wasn't there an objects stuff? Or is there the problem cell? Why don't I get... from the tile, I think it was it tile and then objects? Yeah, something like that. So first of all, the cell can be null. Kotlin doesn't know that because it's Java library, so it returns here, from what I know, a cell exclamation mark. Or does this method throw an error if I try to... No, it can return null, and also from that array, it could potentially return null. So we need to take care of that. So here we have cell, tile, and then we want to get the objects. Let's assign it to something. And if objects is not empty, then we want to do something. If object is not empty equals true, then we want to do something. So let's make a breakpoint here, and hopefully we stop here at least once, which would help us to understand how we can parse this collision information out of it. So we stopped in this breakpoint. We have objects, and we have, there could be, of course, multiple collision objects, which will help us in the future. As I mentioned, because I want to also use the collision editor in here to make the collision shapes for the characters and other objects in the game. So we will have a tile set with the character and objects as well. And then we use the collision editor to create some shapes for Box2D to have some cool bodies and don't just create them manually via the code. Also, we have a rectangle. And that one has a width of 14, which does not make sense in our case because that's in pixels. We have a 16 by 16 tile set, so we need to scale that as well with our unit scale to get the correct information out of it. Okay, good. But in the end, what we want to do, so we now know that we need the object's information, and there for each collision object, that's a long word, call object, we'll make it like that. We want to do something in here. And that was the feedback actually from someone what he doesn't like about Kotlin, that you have so much nesting in here. To be fair, in that case, in Java, it will look very similar. So you don't get rid of it, but we will improve that or refactor it at the end of the day. Most likely, we will just have an extension function where we have something like map for each cell, and then we have all of that extracted, and we just get a valid cell in our callback action, and then we just work with that. So that one we will beautify a little bit at the end of the day. For now, we want to spawn here a single entity. So spawn entity, and there we pass in the collision object, and that one, no, we pass in the entire collision object. And we also need the X and Y coordinates because the collision object, I think that makes sense, because the collision object is in local coordinates, let's say, to the tile itself. But, for example, that one here has a different location than in the end when we spawn it, because it's 4 tiles to the right and 4 tiles from the bottom up. So we also need this location of the tile itself, not just from the collision shape, we also need it from the tile itself. I built an app with Kotlin. Can you check? I can, but not today and not now. We can do that maybe in the next stream. So no, I didn't want to do an abstract method. That was wrong. I want to create a normal function. So that is the cell X, which is an integer. Then we have the cell Y coordinate, and we have the collision map object, which in our case is not nullable. Good. So from the collision object, we get the shape, where for now we know it will always be a rectangular shape. Is that then rectangle map object? Yes. Okay, so there are these different map objects. There's a rectangle map object. I think there is also a circle map object and maybe a polygon map object. Yes. So that's the first thing that we need to do. So when collision object is rectangle map object, then we do something, and there we should actually get the rectangle out of it, which is good. And with that information, we can create a box2D box, I think it was called. And that is all that we need for today. So to create a box2D body, we need certain things. So this spawn system definitely needs the box2D world, which is the box2D physics world. And what I like to do, that's a little bit unfortunate, but there's a name clash with the world from our entity world and with the world from box2D. So what I like to do here, I don't know where is the best way to put it, but we can create a type alias and call it physics world. And that is just the world of box2D. This one here. And with that we can use here instead of calling it world. We can always refer to it as the physics world, which makes it a little bit more clearer. We could also make a type alias for the entity world and call it entity world, but that one I just stick to it as a normal world, and that one is really the physics world. Also, let's call it physics world instead of box2d, because if for whatever reason we want to exchange it with a different physics library, we can do it without renaming the variable name. Good, so we have a physics world, and with that one we can then finally create a body, if I'm not mistaken. So there should be the possibility to create a body. The body type in our case would be a static body, so would be good if we can pass that at import for the body type. Yes, if we can pass that here to the spawn method, because we might want to reuse. Yeah, let's not make it too fast with the refactoring stuff, so let's stick to that. But if we want to reuse that maybe also for dynamic and kinematic bodies, we could do that. But for now, we know it will always be a static body, because we are currently just spawning the ground itself. And then we want to have a body definition. And the definition there, we want to create a box which has a certain width. Can we scale this one? No, we can't. Is there a destructuring for rectangle? I'm not sure. No, that's also not available. We might want to add that, makes that a little bit easier. So for now, we just tried it. Rect_x is from the rectangle, the x coordinate. And as mentioned, we want to multiply it with the unit scale, because that value is in pixels and we need it in our world units. So we also have a width and a height. Width and the height. So this is the information that we need. And our box itself, so it has the width of the rectangle. If I'm not wrong, it has the height of the rectangle. And it has a certain position as well, which is the vector 2 of the rectangular x and rectangular y. So that's a little bit of the offset of the box itself. So since we have here, so the box is not at the left edge, it has a little bit of an offset to the right, and also here a little bit an offset from the bottom. So that is this position argument that we are passing to the box constructor. And that, let me think. I think that should be it. We have a body. It's a static body. It's rather simple. It has a width, a height, and a position. The body itself, of course, also has a position, which is the cell X and cell Y, but most likely that one also needs to be multiplied because it's in pixels. Then there is something which is called fixed rotation, which we want to set to true as well, because the ground cannot rotate. So that would be if you want to, that your body can rotate. If you need that for whatever reason, then the fixed rotation can be false. I'm not sure, is a static body anyway always fixed? There I'm not 100% sure. But yeah, just to be safe, we set it here that the rotation is fixed. And I think that's all that we need. Yeah, I think, the user data. Yeah, that comes later on. So just let me write it down that we don't forget about that. So to do user data set entity. So we need to link our physics body with the entity of our entity worlds, because that's important for the future when it comes to collision handling when two physics bodies collide with each other, then we need access to some information. Like, for example, is one of these physics body our player and the other one is maybe, I don't know, a boulder or needle or whatever, and then we want to apply some damage, for example, to the player. And to have this information, we link the physics body together with the entity itself, and that is done via this user data field in Box2D, where you can set arbitrary data. It's just an object in Java, and yeah, what we are assigning is then the entity itself. So let me think once more. So currently we are iterating over the entire map, and for every cell that we find which has some objects, there we are creating a Box2D body, which is a box which has the size of the rectangle, which correctly uses the position also from the rectangle and also considers the cell position itself. And I think that's it. So if not, we will see if something is not working, then we need to fix it. What we need to do in our game screen. So currently we have here a world block, and above that we will create a physics world, which is, I think it's called create world. That's a KTX extension. And gravity, I think by default is the Earth gravity. Let's download the sources so that we get the correct information here. So gravity is actually 0 by default. I thought it's Earth gravity, but that's fine as well. And as allow sleep is true, which means that certain bodies in our physics world can sleep, and that saves a little bit of processing time. So imagine if a body has no force and no impulse applied, so it's just static because nothing is happening to it. It's maybe also on a flat surface. Then in Box2D, you can set it to sleep, which saves then some processing time every time we want to update the world simulation, because bodies which are asleep, they are somehow treated in a special way. So in our case, I think that's good for now. For sure, we want to change the gravity 100%. That does not make sense for us. We want to have here Earth gravity for now, and allow sleep can be true. That's okay. Then we need to add the physics world as a dependency so that we can access it in all of our systems. And here I forgot to inject it. World.inject and import this method to make it a little bit shorter. So that fixes that compile issue. Also, a physics world needs to be disposed. Yes, but there we can call again this safely stuff. Why can't we call it here? The reason is that this world, that's from the Flex library, and that has nothing to do with LibGDX. So you can use Flex in any application or game that you want, not just in LibGDX. And this dispose safely is an extension function from LibGDX for a disposable resource. And yeah, but that is some LibGDX specific stuff. That's why here we don't have a dispose safely. Just in case you were wondering. Good. We would need one more system to update the simulation every time. But for now, we don't need that, I would say. The last thing that we need is in our render system. There we also need Box2D. Is that actually maybe something that we should put into a Box2D debug render system, that we render then all the different shapes of Box2D? I think that makes more sense as a cleaner if we put it into a separate system, and let's call that physics render debug system, something like that. And there we have again an interval system. And I think that one must take the physics world for sure. It needs to override a method again. And in here, we can now create the box2d renderer, which is a box2d debug renderer. And there we need to, we actually don't need to pass in our world. Okay, interesting. But what we do need is the dispose method, because this debug renderer needs to be disposed again. And finally in here we can then render, and there we need to, okay, here we need our world. So here we have, we pass in our physics world and the projection matrix, which would be from our game viewport. So there we can take over something from the render system, this piece of information here. So in here we get the camera and then the combined. So we only need the camera actually. Yeah, let's get all of that, to be honest. Because in theory, maybe before in the render system, we are rendering with a different viewport at the end. So for example, for the user interface, we are maybe rendering the user interface at the end with a different viewport. And then to get here the correct result, we need to apply the game viewport here once more. And then we can apply the game camera. I just made a typo here. The game camera here correctly. And that's it. So the physics render debug system needs to be added to our game screen as well. Maybe after the render system. And those are all the puzzle pieces, I think, that we need. So let me quickly check once more. So we have the physics world, which we are disposing. That's good. Then we have the spawn system, which is creating some box2d bodies here below. And these bodies should get rendered in our physics render debug system with the box2d renderer that we are also disposing, and with this render call here. So I'm pretty sure that that is for sure not working right now. I would be very surprised if we did not make any mistake, but let's see. Haha! So first of all, we are seeing something, which is not that bad, but the bodies are not at the correct location. I have an idea already about that, but I let you think about that yourself because I need a short break. We also have now multiple draw calls, which makes sense because the box2d debug renderer is a shape renderer, and I think that one has its own draw call stuff. But we are not that far away from what we want to achieve today, which is good. So I will play some chill out music for you guys again. Not sure if it's too loud. Sorry for that if it is too loud. And I need a short break. I'm back in 5 to 10 minutes. See you soon. You can think about why that is rendered here incorrectly and give me your guesses in the chat, and then we will find it out together what is wrong. Hello, my friends, I'm back. Maybe you forgot to multiply the coordinates by scale size. That's a close call. So my guess actually is that this multiplication is wrong. I think. I'm not 100% sure, but I think. The reason is that, from my understanding, the map width is 10 and the map height is 10, which is actually our world units. And we go through here from 0 to 10. And this is not the pixels, so this is really the world coordinates. So position 0, 0. Here it would be 0, 0, 1, 0, 2, 0, 3, 0, 3, 1, and so on. So that's why when we multiplied it here with the unit scale, which is divided by 16, it goes down to here and they are all very close to each other. I think that should be the problem that we had. So when we start it now, I hope that everything is in the correct place. It's better, but not perfect. Why? That's a little bit surprising now. Oh. That's really a little bit surprising now to me. No, that's that's completely wrong. I don't get it, to be fair. Is it a problem with the rendering? No, it cannot be wrong because we set here the game viewport and we render it with this game camera, which is part of the game viewport. So that should be correct. Looks like the center of a tile. It's somehow shifted in my opinion. So it's a little bit to the left, but I'm not sure if that is a problem now with our spawning or it is a problem of the rendering. Because why would it be? No. I think I have it. Is the X coordinate correct? Not sure. But one of these. So two things, sorry. One of them is, I think the Y coordinate is maybe the other way around in tiles. That is one thing that I have in mind. That tiled, I think, is going from top to bottom and we are maybe going from bottom to top or the other way around. And the second thing, that is with your comment, I think this position is not making a real offset. It's maybe... Not sure, is it maybe moving the center somewhere else? So what would be easier maybe? So let's do it without this position argument. What result do we get then? Looks a little bit better in my opinion. And now let's add here the rectangular X to the position. And you're right, and the position of a body is always the center. So this is the center location, and then the box is wrapped around. Haha! That's a good point. I forgot about that. Box2D is working differently than I thought currently how it works. So when we have a box, there's always a point. So this is the position. Oops. This is the position that we set in the code, the body position, and the box is then centered around this position. What I actually want to keep my mentality in a safe spot is that the position should be the bottom left corner. And the box should then just start from here. That makes it easier for me to understand where things are drawn. Also, if I want to refer, because from an entity point of view, the position for me is always the bottom left corner. That's, I think, a normal stuff for when you have a sprite. So that would be a sprite. And for the sprite in LibGDX, the position is either the bottom left or the top left. I cannot remember. I think it's the bottom left. And in Box2D, for sure, it's the center. So that is correct. So to fix that, we would need the position. Let me quickly think. So the position is the cell. That makes sense. That is what I want to have, because the cell is also most likely bottom left corner. And the box, I need to shift it. So to make it start from this position here, we need to give it the cell X, half of it, and the cell Y, half of it. Is that correct? That's not correct. We need to do it like this. So half of the width and half of the height to the right. Then it should be the bottom left. Let's see. Are we getting closer? Yes, I think we are getting closer. What is a little bit weird, why is there a bigger gap between those two? And those are perfectly aligned. Okay, but that looks a little bit better. And I think the last thing is, so this is not 100% correct. We still need to include this rectangular offset itself. So maybe something like that. And ta-da! I think that's it, right? That's correct. It's a little bit stupid that it's drawing it in a green rectangle and our graphics are also green, but I think that's really good to go. Can you change the color, how it's drawn? I never tried that, but can you do it? Public final color. Oof. That's a new color, something. So that is, what do we have? We have static, right? Little bit of red, a lot of green, little bit of blue. I think shape static is the color that we want to change. So let's do that. Shape static, set, and we make it now red. I hope that now we have a red color for the static shapes. Yeah, that looks a lot better. And now let's compare that. So first of all, thank you, Neftatni, for your comment. That's guided me into the right direction. And now let's compare it with what we have here. First of all, I want to get rid of this annoying stamp here. Just don't select anything. Okay, good. So it starts here, so next to this black pixel here, and then we have the light green and one line of dark green. So next to the black one, light green, and one light of dark green. That looks good. And to the right, we are in the light area, but not in the black area, which is also correct. And the bottom here is above that second black line here. Yeah, I think that looks perfect. So we are matching the tiled editor. So everything is good. Hello, Sergey. Greetings back to you. Perfect. So spawn collision objects for the tiled map. That's done. It's not, we are not supporting everything, but that's already done. And the last thing for today that I want to do is then link the box 2D world with our entity world. But before we do that, we make a little bit of a refactoring to make the code a little bit nicer. So first of all, here we set the static color like this. I like it if certain things, if they belong to each other, if they are grouped together in Kotlin like this. So we have here this red color that looks good. And which one was ugly? I think the spawn system was incredibly ugly. So first of all, this comment is useless. And here we want to have more like extension function, I would say, for a tiled map. And then maybe cells for each, or for each cell. For each cell, maybe let's call it like that. And what you can do, you can then execute an action which takes a cell as an argument, which I think also the cell, didn't we also cast the cell itself to something? No, we didn't. So the cell, then also the cell X position and the cell Y position. And do whatever. And I forgot here to write function. Good, so that means that that stuff that we have here, let's move everything to the top here. Instead of map, we have here this. Then this is also this and this. Oops, that was wrong. This and this. And we also need to import the cell from tiled map tile layer cell. Then, so we have this filters instance, then for each layer, then X, Y, blah, blah, blah. Then here we get the cell. And do we also add here the check with the objects? No, I wouldn't say that. That is then too much magic inside one extension function. So here we will just do something like that. Then call action, pass in the cell, pass in the X, and pass the Y. And this extension function allows us now to write here for each cell, where we get the cell X, and the cell Y. Where I'm currently thinking, why would I even need that? Because the cell itself has this information. But let's see. We can get rid of all that stuff. Remove those two lines here. And remove that one. Oh, and here we need to pass in the cell question mark. And that's it. So here we have a cell X and cell Y. But I'm wondering if we need that, because doesn't the cell have its X coordinates as well? No, it doesn't. A really, really interesting data model that they have here in the back. A little bit inconvenient, to be honest. But that's it. For each cell function could be inline function to avoid creation of lambda. Ah, that's also a good point where I wanted to cover something today. Don't let me forget about that. It was the last time we had this tiled map renderer use optimization. There we also introduced an extension function, and there we also can beautify it a little bit. Okay, so last thing. Ah, wait, the cell in here cannot be a null cell because we checked that here. It's for sure a normal cell. And a cell, I guess, must be connected to a tile? Or is it possible that a cell is without a tile? I don't know. Maybe it can be without a tile. So we leave it like that. So that's now a lot easier. Spawn entities is simply a loop for every cell in our map. Currently, from every cell, we get the different objects. And then for the collision object, we spawn an entity. I think. Without let. Ah, you mean here? I think because the cell can be null, we need the question mark here. And with question mark let, it's basically this if cell not null check, then do something. That's the short way to write it. I think that's good. I'm happy with that. One more thing, what I want to do. I'm wondering why is that not part of LibGDX math extensions? Isn't there a component one? We have that for vector. It's only for vector. Ah, okay, so there's no rectangle stuff. That's also a little bit interesting. Might be worth that I make a contribution later on for libkdx. Or you do it yourself if you are motivated. But we might need some additional stuff here. So let's make a math file. And in here we put some extension functions. So what we want to have is component one. Is this just a normal function? Wait. There's an easier way to do that. We can go back. We can say that instead of that piece of code here, we want to have something like rect x, rect y, rect w, rect height. And this is collision object rectangle. Then create extension function component 1, 2, 3, 4. Exactly. And do it. Choose target class or interface. It's really rectangle in that case. So now we have a template, and that's the one that we want to have as an extension. So it's an operator function. And from a rectangle, from libgdx, and component 1, and it gives back something. That would be the x coordinate. So it's a float. Then the same for 2, 3, and 4. So component 2, 3, 4. The second one would be y. The next one would be the width. And the last one would be the height. I think that's very intuitive, at least for me, when I think of a rectangle. It's x, y, width, and height. It's always like that. And with this, we can now destructure this rectangle and haha. We, of course, need to unit scale now everything. Is there a way to directly do that in here? Otherwise, let's just put it down. So we have the rectangular x here, which we multiply with the unit scale. We have the width, we have the height, we have the... Oh, got it. It's a lot of stuff. So the position, let's put it down here. Then. Okay. lot of multiplications. It should still work. Let's check. Yes, it's correct. Do I like the formatting here? Yeah, it's not the best, but let's roll with it for now. I think it would be cool if somehow in here I can multiply that already with the unit scale. We could do that in the extension functions directly, but we might want to do that all the time. Maybe we just work with normal rectangles and that's it. Another thing, maybe someone had the idea that in here we can scale or multiply every single component of the rectangle directly somehow. Wasn't there a scale function or something like that? But anyway, there you need to be really careful. That took me quite some time in one of my games. When you modify the original tiled map object, so for example, this collision object in here, if we would scale that, then for the next cell, where we also get then this same object again, it is already scaled and you scale it 2 times, 3 times, whatever. So never touch, I would say, never touch the original objects that you get all from all these tiled classes. Always work with your own stuff. And if you need to modify it, really just do it on your own objects. Never do it on the tiled objects itself. Good. So the last thing, as mentioned, is that we now want to connect the physics world with our entity world. So what we need is an entity. And do we need more? For now, we don't need more. Do we even need a component? Yes, we do need a component. So we have a component package, and in here we have a physics component. What I also do now differently nowadays, I don't add components to every component class itself, because the syntax is then a little bit nicer. We can then write something like this, entity physics, which gets us the physics component of an entity, instead of writing entity physics component. Also, it gets a little bit redundant when we have to do that for everything. So when you have to write component all the time, I don't like that a lot. That's why nowadays I just skip the component part in these classes to get to that specific syntax here. I like that more. What I don't have, I think I don't have that yet. But since I'm a lazy guy, but at least I remember where I put the important information that I need, we can go to GitHub, which wants me to verify my account, but I don't want that. Just log me in. I hope there was no critical data shared with you guys. Then in the Wikipedia page, hello Fatih, or yes, my eyes are correct, Fatih. And in there we find a component section, I think. Yes, and in here we have a live template that we can add to IntelliJ, which helps us to reduce a lot of boilerplate typing. So under live templates, then we have the Kotlin language somewhere. And in here, we want to add a new live template. When we type flex C for flex component, we want to paste the following code. Normally, my components are data classes, so I will add that here as well. Then we give it a name, a component, flex component, and application context is Kotlin. Yes. Okay. And that's already it. So we have here flex C, which means now when we type here, we get already the boilerplate code for a component. The only thing that we are missing is that we need to import here the flex component all the time. And since it's a data class, we need an argument at least. And here we pass in the body of the physics world. That's the thing that we need for a physics component. Here also in my tutorials, I used in the past always a component listener, which is thanks to a contribution from a guy on the repository. It's a lot easier now. You can override two methods. There is an onAdd and onRemove. They run in the context of a world. So in here, I could already get the component, which is this at physics. That's the component itself. And this itself is the world in that specific component listener. So in here, I could then set the body and get here, I don't know, the physics world, for example, create the body in here, whatever we want to do. But as mentioned, I try to avoid those delayed creation things nowadays. And also for testing, in my opinion, it's better when you clearly see that when you need a physics component, you must pass a physics body. It's not magically created somehow. You need to pass it to this component. And that's it. The other thing regarding the boilerplate stuff, just that you know it, in one of the earliest versions of Flex, I used annotations which were only working on the Java version, but not for the other platforms that the Kotlin multi-platform project can target. So you could write something like add component, and then it did a lot of stuff that needs to happen in the background. It did that just via reflection. What I want to do with Flex in the future, if I ever have time, is that I also want to introduce an annotation processor. And hopefully, I'm not sure if it would actually work, but the idea would be that you have then an annotation for the component, also for the family of systems and things like that, that they are then getting processed like normal annotations are processed, and that you can skip then most likely that code here, maybe even that one, I'm not 100% sure, because that should then get automatically created via the annotation processor. So it makes it a little bit easier. I think it's not a super big deal because with the live templates, as you have just seen, it's very easy to create a component and this boilerplate stuff, but still a little voice inside of me does not like that a lot. So I try to optimize that in the future in the Flex library at some point. It will be optional, so it doesn't break the existing code, but if people prefer to use an annotation, then they can do it. Okay, so we have a physics component. What do we do with this physics component? We go to our spawn system again. So here we get back a body. Let's just call it body. And now we really want to create an entity. To create an entity, we need access to our world. Since we are inside a system, we have access to it. And there we create an entity. And this entity needs a physics component. And there we pass the body that we just created above. And one more thing. Body.userData, and that one is equal to the entity. I think that's everything that we need. So spawn physics body, create real entity, and by real, create entity. There we might add additional things in the future. So normally what I do, I also have a tiled component. So I can reference an entity to the tiled object itself, that I know where it's coming from, which is also helpful when it comes to debugging. We don't need it here, so we can skip it. And just one more thing, I like to set that here before like that, because then when the body here gets passed into the physics component, it's already complete and we don't need here this entity value assignment. I'm still using 1.6. I'm actually wondering if that ever gets deleted at some point. I don't know how long Sonar type or whatever that host is called, where you publish your artifacts, if they delete artifacts at some point, if they are too old. I don't know. But of course, you can use 1.6, which is totally fine. You see here the difference a little bit with 2.x. I find it more convenient. Also, it's this multi-platform stuff for Kotlin, so it helps with other applications and other target platforms if you want to use it there. And yeah, I think that's it for today. So we created now these entities, which are at the moment totally useless because we don't process them. But it should work. So let's see. Let's start it in debug mode. Let's go. So we see our tiled map here, and we should have in total 1, 2, 3, 4. I think we should have 10 entities. Let's go to our game screen. Let's make a breakpoint in there. And from here, we can get the num entities, which is 10, which is good. So we know we are getting the correct amount of entities. Oh, where are entities stored? I think in the entity service. And there we have a bag for the physics component. And there we should have 10 physics components. Yes, we have that here as well. With 10 different box2D bodies attached to it. And a body's user data, do we see that here? Yes, is linked to an entity. So that one is linked to entity ID 0. And the generation or version count of the entity is also 0. And the next one should be linked to entity 1 with version 0. Yes. Perfect. Really, really good. So what we did is spawn player that is placed in tile. That one we did not do. Let's move that to the next day. So the last thing that we want to do, or that I want to do, is to optimize or give you some idea about this use extension function, how we can improve it a little bit. I guess you won't create a body unless it is visible in the viewport. I couldn't watch the beginning because I was late. Actually, I don't do that yet. So the optimizations that you maybe are used to from my tutorials, for the time being, I skip them. So only when we get a problem, or if something is not performing good enough, then I will do some optimizations. But for now, it's really a super simple approach. So we simply go currently over the entire map. So we have this for each cell function. There we have the total map width and height. We iterate over all the cells that we can find in all the different layers. And we are then simply spawning an entity. So even if the map would be super big, we would still create all of these objects. But I mentioned an approach at the beginning or at some point that, of course, this is not ideal because let's imagine, let's get rid of here. Let's imagine this is our entire map and our viewport is maybe just this one. Then there are some objects, of course. There might be the player, there might be an enemy, there might be some other entity that you have, maybe some obstacles that we place here. So if all of that gets processed during that time, that makes sense. But there might also be entities at the end, like, I don't know, a final flagpole that you want to reach, like in Super Mario, or another enemy like a Cooper or something, and processing those entities here so that the Cooper goes up and down or left and right or whatever. That does not make sense. That's useless processing power. So normally, I think that is also how Super Mario behaves. There is like a virtual area around the player, and in that area things are getting created and processed and everything, and it's a little bit bigger than the viewport, because imagine, let's make it orange, we have here an enemy that can go left and right. Again, let's take the Koopa from Super Mario. If it moves out of our viewport, it would be a little bit strange from a player perspective that when you move to the right, that one hasn't moved at all. So if it just stays here all the time. Also, if there would be a wall, so imagine here is maybe also a wall where the Koopa should collide with and then go back. And that one also then does not really make sense that when it goes off screen, that it just stays there. From a player perspective, you would expect that it goes to that wall and then just comes back at some point. So maybe tactically you want to wait for it and jump on it. So you would expect that it goes to that wall and goes back. And this is, I would say, so maybe, I don't know what is the real size, for example, in Super Mario, and if it works like that, but most likely there's an area like that, which is around, usually centered around the player. And in that area, you are processing all your entities, and everything that is outside that just gets, I don't know, either deleted. I think they even also delete it at some point. Or what I would prefer that it stays there, but it just doesn't get processed. That I think is better. Why do we create entities for the bodies we create? Just to prevent the character or enemies from falling off the screen? Is it necessary? Can't we just create a body? Yes, we can. So there's, especially when it comes to the ground stuff, so things like that here, where we just need a static body for the collision for the player, you don't need an entity at all. Maybe we remove that later on, but my thought process here is that when it comes then to collision handling, so when we have then a real player and it's getting a contact with these other bodies, so contact is the collision, how it's called in Box2D, and when we have this contact between two bodies, then I just prefer that they are connected to entities, because then it's easier for my logic to know what it should do. So it would then know body A is with the player entity. From the player, I can get, for example, hit points, and I don't know if it's immune to fire. And from the ground entity, I would maybe get what kind of type it is. So maybe it's, for example, a flame. And then I would know, okay, the player moved on a flame entity, so it should get some damage. If it's just a Box2D body, if it's just for collision, I think that's good enough. If it's maybe for simple things like I just mentioned, just to detect if it's a flame or whatever, you can maybe just get away with the user data field of the physics body and give it some property. But if you want more advanced stuff, and I would say also to be more flexible for the future, it's better to just link it to the entity itself. And then you have all the information available and can also link and attach every information to the entity that you need. And that might be useful for your collision handling or contact handling logic. That's the reason. Good, then the last point, so tiled map renderer. That's a really small one. We have our render system. And last time we made there this extension function, so this use, and we called it action. And what I actually did, I looked up from Kotlin, there is a use function or use method for a closable object, if I remember correctly. Yeah, from a closable. And there are two things, so let's just copy and paste that here. Two things that we can improve here. The first thing is that already someone mentioned in the comments before, it was Neftatni, if I'm not mistaken. So we can make the function inline, which means that the block that gets executed is basically put exactly at the place where you call this use function. and that reduces the call stack a little bit. And I think it's just some optimization stuff and it's a little bit better. And the other thing, I would say, when you use a similar function from the standard library, like this use function here, you should also stick to the same behavior, which means the block, first of all, the action should be called block, in my opinion, and the argument is in our case, the map renderer itself that should get passed, and the return result. In our case, it does not make sense, so we don't need the result here, but the argument should be the tiled map renderer itself, because then here it's just me and it will be only me, but if other people would maybe work with that engine, or maybe if you use this as a library or whatever, then it's easier for them if it behaves like the normal standard Kotlin function. So that's why, first of all, we make that here an inline function. That's the first thing. And the second thing is that the action is called block. And the argument is not the batch, it's the tiled map renderer itself. And that's it. I think our code still compiles because we never accessed here something. And the batch that we might need inside here, that was the idea why I passed the batch initially. First of all, we can access it here anyway because it's part of the render system. And the other thing is that you can still get it from the map renderer itself, so it's not lost. So that was a minor thing that I wanted to change to be more consistent with the Kotlin standard library. And with that, that's it for day 2. We achieved everything in, what was the time? About 1.5 hours, I would say, which is more than good enough. I'm fine with that. So the second part of day 2, which I won't do today because I'm just too tired, sorry for that. The next time we will really create then the player itself. We will place it in tile. We spawn it. It will most likely be very similar to what we did today, but we will have more components because the player really needs it's not a map object that gets rendered. It's then a separate sprite with its own texture that we need to create and all of that stuff. Then we might want to play a little bit around with the collision for the player. So there, as I mentioned, we will use tiles. I want to use a separate tile set with the player graphic. And then in the collision editor, we will place a circle for the head and the feet most likely. And in the center, a rectangle for the body of the player. And with that, we will then also support different shapes with this body creation of Box2D. And if we have time, let's see, maybe that's even another day then, we will add then some, I think we can add that on that day. That should be quite simple to just get some random movement behavior for the player so that when we press, for example, D, that it gets pushed to the right, and with A, it gets pushed to the left. This very, very simple keyboard input listener, we can also do that then the next day. And after that, then there comes, in my opinion, for me personally, the highlight of this project. It's then improving the controls of the player. So there's certain things that we can do. And I never had a really, in my opinion, a good control behavior for a platformer. It was always a little bit weird when you were falling down and moving and jumping and so on, because the physics simulation, of course, tries to be realistic, like the normal physics in our daily life. And in a platformer, of course, you don't want that. It's usually a very unrealistic movement. So we need to fiddle a little bit around with Box2D to get some cool behavior. It will be, for sure, it will not be perfect and not as good as some Mario platforming games, but it should be better than just some other games that I made in the past, and that would be my goal. So day 3 is the exciting one for me. I think that's some cool fiddling and fiddling around and then reading into certain topics and get some cool results with it. Okay, so at the end of this project, just as an example, can you write a method that allows the character to overcome obstacles from start to finish using GDX AI's pathfinding algorithm. Ooh, interesting topic. I know that the AI module has, I think, A star pathfinding built in. And you need to fit or feed it then with the information. So where are your cells? Is a cell pathable and things like that? And then the algorithm will find out a possible path. And that one we could rather simply then move. So maybe not with our real entities because they have collision and everything, but we could make like a ghost entity and that one just follows the path step by step. So imagine we have currently a map like this. Let's also make everything visible again. And maybe there are some obstacles. So I don't know, here would be a wall. And with the algorithm, it should then find the path like that it goes to the right, then up, right, down, right. That should be then possible. And then just a normal sprite without any collision and whatever. We could then just follow that path here. That should be possible. I don't want to promise it because I'm not sure if we will have time for that. But I added to the day X. So if we have time, then we can do that. How do I write it down that I don't forget it? Use GDX AI pathfinding algorithm to move a sprite from start to end along a correct path that considers collision obstacles, something like that. So if I understood you correctly, that should be it. And yeah, we can try that if there is time. But I don't want to promise it, sorry. I will try. When will be day 2, part 2? So that one here. Let me quickly check my phone, which is right next to me. And what plans do I have this week? Almost nothing. So tomorrow I don't have time, but on Thursday most likely. So Thursday should be possible again for a stream. Will be the same time, so around 7 in the evening Central European time like today. And there we can do the second part of this day too. And before I forget it, let's also commit all the stuff that we made here. The raw assets, we should we exclude it? Let's also commit the raw assets to the GitHub repository. It's anyway for free. Microsoft doesn't care if I upload their additional kilobytes. And what we can call that here, so add ground entity spawn logic. I think that is what we did today. 39 errors. Yeah, we don't care. It's the tileset thing where the IDE thinks it can understand it and tries to identify errors, which are no errors. Ja, gut. What do you normally work on? It's obvious that you use many languages. With languages, you mean programming languages? There from, let me think, what kind of languages do I really know actually? I didn't want to open that one. Don't I have just normal Notepad? Is it called editor nowadays in Windows 11? Whatever. So I started initially with C++ when I was around 17. Then at university, we also had C courses and Java, of course. We also had there, I think it was Haskell and OCaml. That's some functional programming languages. Then one language, no one knows it, but it's called Chess, if I remember correctly. That was Warcraft 3 mapping scripting language. If you ever played Warcraft 3, there is a map editor, and there you can also make your own script for spells and things that you can create custom maps and so on. And that scripting language was Chess back then. I'm not sure if it was written with 2S, but I think so. Then, of course, JavaScript, TypeScript, because I needed that for some front-end stuff at work. I know Kotlin nowadays, which I learned by myself. And that's it. And also because of work, I can read COBOL. I cannot write it, but I can read and understand it. And I can also read and understand C#, which is, in my opinion, very similar to Java. But that's it. I heard a lot about Rust, and one colleague at work, he loves it. I looked a little bit into it, but to me, it's more like this C++ stuff where you need to be careful with memory allocation and free it correctly and things like that. And I don't want to bother with that. I want to focus on the things that make fun, and I don't want to bother with this low-level stuff. But in the end, I think that should be it. Okay. One thing, but there I'm also not an expert. There was also Lua, which is also a scripting language, which you could also use for Warcraft 3 mapping. But that was like over 10 years ago. Maybe it's even 20 years. Damn, I'm old. Like 20 years ago, I cannot remember that, but I know a little bit about it. I think that's it. It's actually quite a lot. I'm surprised that I learned so many languages. I for sure could not write good C and C++ code anymore. It's just too long ago that I used it. But I feel very confident with Java, Kotlin, even TypeScript, JavaScript. I think those are the 4 languages where you can make full stack projects, and there I feel confident enough to use them. I hate Haskell. I also hate functional programming languages. They are fun sometimes, but I'm just missing that I can group things together in a class from time to time and just use them this class. Working purely with functions, that's not what I like. Scala, I heard about it. There were always the fights in several comments areas where the Kotlin guys and the Scala guys are arguing which one is better. Python, I forgot about that one. So Python I actually can also read, and I learned it a little bit, I think 3 or 4 years ago, where I helped the boyfriend from my sister. He started programming and he chose Python, and there he had some questions. And that's why I had to look a little bit into the language, how it works. So for example, what is a map in Python and a list and so on. So there I used a little bit of Python. And I know that the data scientists nowadays, they use it a lot. Seems to be an easy to learn language, and I think has a lot of libraries and things. COBOL is older than me. I think COBOL is even older than me. And it's also not a nice language to program in. At work, I sometimes need to replace old COBOL stuff with more modern technologies. And there's sometimes COBOL code, it's like sorting a list and filtering out duplicates. And that is hundreds of lines of codes to make that happen. And then when you use Java, it's just 1 or 2 lines and that's it. So we can be happy that we have all these convenience functions. Are you a web developer? No, unfortunately not. So I'm a full stack developer actually, with focus on the back end mainly. I know a little bit of front end and I can achieve certain things, but I'm very bad when it comes to styling, so CSS stuff, Flexbox Grid and all these things. there I'm not so good. And with not so good, I mean I'm very, very bad with styling stuff. And I'm also not an expert, so I know React a little bit, I would say, maybe a little bit more, Angular a little bit. So those are the two front-end libraries that I mainly had to use or adapt that work a little bit. So write a component, link it with a service, call some backend stuff. Those things I can do, but I'm no front-end expert. I would like to focus more on that and hopefully at work by the end of this year or beginning of next year, I get into a pilot Angular project where an Angular expert is doing some really fancy stuff there with the most recent version and all of that. And then hopefully I can learn a little bit from him and become more of a front-end expert as well. So there I would say I understand how things work and I can adjust existing things, but especially when it comes to styling or best practices for bigger projects, there on the front-end side, I'm not there yet. But backend, I am quite confident. So database stuff, business logic, servlets and all these things. So Spring Boot, that's where I currently live. Gets sometimes a little bit boring after over 10 years to write REST APIs and integrations and things like that. But still, it's fun. Sometimes it's boring. I think like for everyone, some parts of your daily work, they are just sometimes very boring. But in general, I'm quite happy in the area where I work and what I do. Backend work is more fun than front stuff. You don't need to bother with styling, etc. Yeah, I like the backend stuff a lot, especially the last couple of years. I'm also got more knowledge about the architectural stuff. So how to design software, how to link certain pieces together, that you don't have one monolithic huge project, that you split it up into several projects and link them somehow together. In the backend architecture world, that is some fun stuff that I like. Here also, because especially the cloud becomes more and more important, it seems, in the last couple of years. But with the clouds, unfortunately, I don't have a lot of experience because the customers that I usually work for, they have everything on premise, so in their own house. They want to move to the cloud, but it's always usually too expensive, takes too much time. And it's more like plans for the next 5 or 6 years where they want to move to the cloud. But I'm also looking forward to have a project with maybe some Amazon cloud stuff. There I saw a few videos on YouTube which looked quite interesting to get some experience there as well. But I am, to be honest, and I tell you something, you cannot be an expert everywhere. It's impossible to know everything. So just focus on one area that you like and where you feel comfortable. For me, it's the backend stuff. That will be then your main job most of the time, but going overboard from time to time and also look into other areas like front-end or cloud stuff or continuous integration, CI/CD pipeline stuff. When you get some experience there, in my opinion, it helps because you have a better understanding of the big picture, but you cannot be an expert in all of it. That's simply impossible. I like front-end stuff, but for internal use tools, because no designers and other people wanting me to move something by 3 pixels because that is in the design. Yeah, I think what is quite difficult actually is the responsive website. So I made a couple of websites, some hobby projects, and it's actually then it gets tricky when you need to support different devices, so not just your normal desktop, when you need to support then also mobile phone or whatever, and when people can simply then move around is it also called viewport, I guess, in the browser, where you can make things smaller and bigger, and to make that really look good on a lot of different solutions and devices, I think that's not so easy. It's a little bit easier, most likely, than it was in the past, because also the browsers get more and more, or get better and smarter with handling layouts and so on. But still, to make it really then look good with all the different possibilities, I think that's quite a challenge. And I will never be there, because personally, I also hate it. For me, always, like you mentioned, so having the element at the correct location with the correct pixels or whatever, I hate that. I don't like that a lot. There was in Java, maybe some of you know Swing, or what's it called? AWT or SWT, I cannot remember. So this Java user interface thingies at the beginning, where in the code you define the layout, then into the layout you added your different elements, and then somehow it's calculated where everything needs to be. That is also total hell, because that was one of my first jobs, developing a rich client platform. So with this Eclipse IDE, that is always the base for a rich client platform project. And when you were, like I did it before, when you made the window a little bit closer, there were then hundreds of events triggered by the internal system. And then the user interface was flickering. So you had to put in some hacks to avoid that everything gets refreshed and re-rendered all the time. And it's pure garbage. It was at the showcase nice to see, and it looked amazing. But in reality, when it comes into all the little things that end users are doing, it's a hell to maintain and to make it look good. And that was my experience always with user interfaces, that they are quite annoying to get right. Easy to start and easy to get something going, but to make them perfect, that's always a long, long journey. Okay, guys, I would say that's it for the stream today. I thank you for watching, and hopefully see you then again on Thursday. Wish you a nice evening, and bye-bye. They removed JavaFX from JDK. Yeah, that's true. I think that's a separate library now, JavaFX, from what I know. I never had to do something with that, but a friend of me at work had to do something with it. But yeah, we could talk for that for hours. Let's do that in the next stream. I need to go watch some more random stupid TV show and then go to bed. Bye-bye.